Okay, while the projector's going up. Yeah, cool. So, it's been a while since we've done inequalities. But since it's been a while, I think people generally have two kind of initial reactions when we try and solve an inequality like this. Who am I going to pick on? Jesse, what do you reckon? How could we solve this? Yeah, just like what we want to do is, well, what I reckon people want to do is they want to say, okay, x squared minus 9 greater than 0. So let's just start rearranging. So I get x squared greater than 9, and then we've got to take square roots. So don't forget the plus or minus. So you got plus or minus 3, and that's the answer. X is greater than plus or minus 3. And we can test it out. Like if I substitute like 4, which is greater than 3, put that in there. 4 squared minus 9, yep, that's greater than 0. 16 minus 9, 7, so that's good. Let's test greater than minus 3. So what's something greater than minus 3? Think about your number line, right? So you're looking at the numbers above negative 3. So for example, like negative 2. So let's substitute negative 2 in there. So I get negative 2 all squared minus 9. That gives me, what does that give me? Okay, that's not greater than 0, right? So that doesn't work. That's not good. Another initial method that people think about is they say, okay, alright, why don't I just think about it intuitively? I can say x squared minus 9 is greater than 0, so I can just plug in numbers that are, well, obviously, like 3 squared minus 9 is 0. So then I can just say, like 4, and 5, and 6. Okay, so all the ones where x is greater than positive 3 work. That's all well and good, but if I give you, for example, negative 4 all squared minus 9 is also greater than 0, so that also works. So this solution is sort of correct. The problem is, though, that you miss out on half of the solutions. And the key is in this inequality. In this inequality, you have to be careful how you approach it. So this one's not good either. In chapter 3, you learnt about using the number line method. I think the number line method is good, except sometimes it can feel a bit clunky. So, because we're so used to working with parabolas, right, we want to think about, okay, what does this look like graphically? And this is when the roots of our quadratic equation are going to come into play. They're really important. If I just graph this guy really quickly, I've got x squared minus 9. Okay, you can see I've got a parabola here. And remember, what was the question? We were saying, when is this equation, or when is this parabola greater than 0? And you can see there's two key points here which are important. The roots of this equation, I've got negative 3, and I've got positive 3. And they're going to be greater than 0 outside those bounds, right? So, really, the solution to this is, for all the values, which x is less than minus 3, which is everything on this side here, right? I've got the red line being above the x-axis, and all the values greater than 3, I've got it positive. So, I can say the solutions for this one are x less than minus 3 or x greater than 3. Okay? Those are my solutions. And I've just shown you the graphical method upon which we can do that now. Okay? We don't have to rely on constructing a number line and then trying to test points. We can simply graph the parabola or quadratic function and then plug that in. Let's see how that works. That does loss. So, how do we graph things really quickly? Factorizing is going to be key here. So, we've got x squared minus 6x is less than 0. So, you can treat, for example, we'll just say let x squared minus 6x equal to 0. And then we've got, I think a better way to say, we'll say let y equal to x squared minus 6x. And then so we've got y is equal to, let's factorize. So you take your x terms out, you've got common x terms here, x out. Okay, what was that? Well, let x squared minus 6x equal to 0. And then here we want to factorize, so it's going to give us some information about the graph. X outside of x minus 6 equals to 0. And then we really want to find out where do our roots occur. Okay, so our roots are going to occur when this equation is equal to 0. And we have two cases, right? We've got when x equals to 0 or x minus 6 is equal to 0, which is just going to be x equals to 6. So I don't even have to think about, really, plotting any points anymore. I can just quickly say the roots, right? The roots where the solutions are equal to 0, where it touches the x-axis, when x equals to 0, and when x equals to positive 6. Problem with drawing the parabola now is obviously, hang on, which way does it go? Remember, how do we determine its concavity? Happy face or sad face, right? If there's a positive coefficient, it's going to be happy, right? Negative, it's going to be sad. So in this case, obviously it's going to be happy, right? So we've got probably going like this. And don't be too concerned about, vertices or min and max values. Remember, we're trying to solve the following. When is this graph below the x-axis? When is it less than or equal to 0? And you can see that region is going to be just there. It's going to be in between when x is greater than 0 and x is less than 6. And that's all you got to do. Easy. Let's do another one. What should I do? Let's do here. X squared minus 3x plus 2 greater than 0. That's better, right? 13. I'm running out of battery and I'm about to get kicked out soon. So, see if you can beat me for this one. Who's got good factorizing skills? Let's go. Race. X squared minus 3x plus 2 equal to 0. And I want to find its roots, so we get x minus 2, x minus 1 equals to 0. So, our two possibilities are x minus 2 equals to 0, or x minus 1 equals to 0. So x is going to equal to 2, or x equals to 1. Okay. And then I draw my mini graph again, because I'm really only concerned about the regions that I've got. When x is to 2, or when x is equal to 1, I know this is going to be a concave up parabola, because the coefficient of x squared is positive, so I can draw it up like that. So the regions now where it's greater than or equal to 0 are going to be defined by these regions, right? I've got on this left-hand side of the graph, and on this right-hand side of the graph. So the answer to this guy would be when x is less than or equal to 1, so just be careful with the inequalities, with the less than and equal to's, right? Or x greater than or equal to 2. Okay. Alright, last one. Do I have another example? Minus x squared minus 25. Does that work? Less than 0. Now I've already done positive examples here, which probably isn't the best, but it's going to work for concave down parabolas as well. But I want to do this example because it's a little bit different, okay? Let's try factorize. What's in common? Nothing. Alright. Time to decimals. Don't give up so easily. How can I factorize this guy? What do you notice? Think about the patterns, right? You have x squared and you have 25, which is in actuality a square number, right? So how can I factorize this expression? I can't take anything out in common. What I can do is I can use the difference of squares. That tells me if I have a squared minus b squared, that's equivalent to a plus b, a minus b. Okay, so next thing I want to do is I say, alright, well let's go from here. Let x squared minus 25 equal to 0. So I've got x plus 5, x minus 5. And so the roots of my equation, well, they're obviously just going to be positive 5 and negative 5. Okay? And because I'm still working with a concave up parabola, I can just say, well, easy. When is this going to be less than 0? In between these 2 points, in between the roots, this region here in the blue. So, final answer for this guy would be when x is greater than minus 5 and less than 5. Easy peasy.